Okay.
Thank you, everyone. Mute. Bye.
Sorry about that. I'm going to give an introduction for Ronson. Welcome, everyone, to the INDIGE-FEWSS seminar series. This is the last seminar of the academic year. Wow. So welcome. We have food outside. Feel free to have some. And we'll be planning to do another seminar series in the next academic year. Ronson Chee has been practicing in the civil engineering for over 10 years. He earned a BS, MS, and PhD in civil engineering at U of A, where he specialized in water resources engineering. He served in many capacities within civil engineering field throughout his career, including computer-aided drafter and designer, technical discipline lead, project engineer, project manager, client manager, and business developer. His duties as civil engineer include civil design using AutoCAD, performing technical calculations and advanced hydrologic and hydraulic modeling, preparation of technical reports, preparation of design, drawings, construction plans and specification, cost estimation, field construction oversight, preparation of proposal and engineering fees. He's active in the academic research area where he's submitted and successfully published, and he serves in other capacities outside of engineering. He is the board member on the Navajo Engineering and Construction Authority. He also serves as VP for the American Indian Science and Engineering Society Southern Arizona Professional Chapter. He also mentors and provides guidance for engineering students at the U of A. So we're pleased to welcome Ronson Chee and hope that we can also make a connection with our trainees. We have 12 trainees in our program, 3 masters and 9 PhD students across the STEM fields. So without further ado, I'll go ahead and give it over to Dr. Chee.
Good afternoon, everyone. Thank you for coming. Carletta said, my name's Ronson Chee. I'm originally from Loop, Arizona, which is on the Navajo reservation. My clans for all the Navajo people are Kintla-Chee-Din Nishle, Hashkan Zoho Bashishchin, Kiani Dashiche, Glasche Dashanele. So that's where I'm from. I grew up in Loop. My whole life, went to high school in Flagstaff, graduated, started U of A here, did the bachelor's, master's, PhD, and my focus has always been water resources. So growing up on the nation, that's one of the big things out there is lack of water, lack of infrastructure, hauling water. You'll see people hauling water all day long for just in-home use for their cattle, for their sheep. So it's been that way ever since I've known it. And even to this day, it's still like that. So a lot of my studies, emphasis, professional life has been focused at how do we fix this problem? We live in the US, we have in the wealthiest nation in the world, yet we're still hauling water, we're still living almost in a third world type society. So that's what kind of motivated me to do a lot of this research and focus my PhD studies all specifically in water resources, engineering, design. And a lot of this is based on, so the work I'm going to present is based on the PhD dissertation work that I did a couple years ago. And sort of just to give you an overview of some of the issues that are out there, how we attempted to solve them. And we're actually trying to get some of these ideas implemented in the nation and just kind of get the nation to buy in on it and some of the agencies that are actually trying to work on this problem. So Indian Health Service, Water Resource Department, the utility company, NTUA. So it's kind of a collaborative, this is how this whole thing was developed. And so this is what this is, I'm gonna just do an overview of it. And since then, so I graduated 2017 with a PhD. But since then, I've started my own business, which is Riley Engineering. And we're a civil engineering firm. We specialize in water resources. So with the idea that we service, tribal communities, help them develop their water resources, help distribute water to where it's needed, and just kind of cater to the native tribes and native populations. So that's what we do. I felt there was a big need for it. A lot of other firms, they don't really cater to the tribes, understand the, they don't understand the problems, like someone that's actually from there. So that's kind of what, just the background on myself. Some water. So here's sort of just a brief outline of the presentation. You can talk about the problem, some of the goals of the study, and some of the, we had subtopics that compose the whole study that we did. One of them is a pipe insulation cost model, and the other is a design module for actually designing water systems, and a decision support model that actually helps decision makers, planners, council members to actually make decisions in terms of which investments, which projects should we actually fund. And then there's so many needs out there. There's so many projects that are needed that you can't build them all at the same time. So what we develop is a tool that actually helps you choose. Let's choose one project, let's fund it, and then we'll move to the next one. So it's sort of a systematic process. So, so here's overview of the problem. So about 10 to 30% of the population still doesn't have running water, and they have to haul water. So this is typical what you'll see. And another issue is it causes a lot of health problems, not having access to clean water in your home, sanitation issues. And another issue on Navajo is we have a lot of abandoned uranium mines that contaminate the water. So, but people actually still use those water sources because there's no other option. So, like you'll see, some of the elders will actually use contaminated water for drinking and for their livestock. So, and they get a lot of cancer. We have a high cancer rate related to that. So it also hinders the development. We don't really have this is probably the extent of our economic development. You have, small vendors selling different products and sort of like a flea market type setting. And there's really no big business. There's no industry. There's no commercial. So the jobs are really lacking. And part of that's tied to we don't have the infrastructure to even support, that type of a city setting or sort of large businesses. So it's kind of like the chicken and the egg. You can either have the infrastructure support the economy, or you can have the economy support the infrastructure. So it's all tied together. A lot of the existing infrastructure is aging. So a lot of the stuff that is out there now has been built maybe in the 60s through like Bureau of Indian Affairs, the Health Service, and it's very old and it's failing. So one of the big issues is it's very expensive to build on Navajo. Everything's so spread out, so diverse, that whereas like here in the city, you have people concentrated in one area. So economies of scale is an advantage for you. But on Navajo, everyone's so spread out that it's very expensive to build a pipeline, going like 10 miles just to service a few homes. So it's not really economical. So we also are in a water scarce region. We're up on a plateau, very few lakes. The big water sources are the Colorado River, San Juan River, and they're very located to the very north. So the only way to access is through canals or pipelines to deliver that water. And like I said, people are scattered all over. We have towns, but they're very small. They're not highly populated, and there's just a lack of money to fund the infrastructure. The utility company strain. So right now, NTUA, they're the utility provider. About 90% of their customers are all residential, whereas like here in Tucson, you have about maybe 30–40% business, commercial, industrial. And when you have those big users connected to your system, they help offset the cost of the operation and maintenance. When it's all residential, you can only charge so much per user. So you have this big gap where your operation and maintenance costs and then your income, and this gap's only getting worse and worse. So the utility companies has a lot of problems. And it's very difficult to design these water systems. There's a lot of uncertainties, and a lot of people are leaving the reservation to pursue other opportunities elsewhere. They'll come to Tucson, they'll come to Phoenix, Albuquerque, just because there's jobs, there's school, there's opportunity. So we have issues like that. So it's very hard to plan for, how do we plan for the growth? We don't know where the people are gonna go. Then you have things like drought, which makes things even harder to plan for. And then you have this economic issue. There's other barriers besides just water. You know, poverty's big. There's a lot of other socio-economic factors at play. So there's a lot of issues. I chose to focus, so I'm a civil engineer. I chose to focus on the infrastructure piece, but there's tons of other aspects to look at. There's health issues, there's you know, schools, and there's you know, healthcare. There's all types of issues. But my approach was, how do we solve this from the engineering side? So overall, sort of a big picture is we have, here's the Navajo Nation. Everything in the gray shaded is the reservation. Hopi's right in the middle. And all the dots you see are homes that don't have running water. And the blue is the existing water lines that the utility company has. And the red is planned or proposed pipelines to deliver water. So you'll see like a lot of them come off of the Colorado River to deliver water into Navajo. And the one from Shiprock to Gallup, that one's actually under construction. And so that's like a large project. It's like a, I think, $1 billion pipeline, water pipeline project. And the other ones are in the works to be planned, or they don't have funding, but they're actually working on them. So if you add up all these proposed pipelines, you're probably looking at maybe, you know, $10 billion of just water pipelines that you're trying to build. Whereas the tribe only operates on about half a billion. So it's going to take years to figure this out. So it's an important problem. It's a big problem. So yeah. So this is just sort of how I piece together how the current planning process is actually funded on Navajo. I put this together talking with all these different agencies, Water Resources, IHS, Bureau of Reclamation. And it's a very linear process. So you have certain people in at the planning and design phase, and then you have different agencies helping with construction. And then once you get to the operation and maintenance, the utility company takes over. But the issue is that they don't have enough customers to offset the operation and maintenance costs. So there's a lot of people trying to help with the problem, but they're not looking at the back end and how do we pay for this infrastructure once we have it. So it's like inheriting a big house and you can't pay the taxes, you can't pay the HOA fees, you can't pay the energy costs to run a big house. So that's the issue they're facing, is they need some income to help fix some of this problem. And at the end, I'll show a revised planning strategy that we're actually trying to change. And another piece we're missing is the housing, like NHA, they're not involved. The economic development folks aren't involved. And we're missing this, long-term planning and sustainability piece from the economics for it to work properly. So the goals, how do we improve the water coverage? We need to make smarter investments instead of just picking projects, instead of people in the chapter making a lot of noise and asking for a project. In my mind, that's not a good way to choose a project. So let's put some engineering into it. We need to select projects that can meet multiple objectives. So Indian Health Service, they contribute about 30 million a year into water pipelines, but they only have a health focus. So if somebody wants to plan whatever it is, a bashes or a business, IHS can't pay for that water capacity to accommodate the business. So they can only design for the home, and then that's it. So we need to change the thinking and the vision to reflect what the whole needs are of the nation, rather than just taking a template that's been put for Navajo. So we want to try to satisfy environmental objectives, health, and economics. So those are the three, in my mind, the three things needed for sustainable type development. And we want to be able to provide a vision for the nation in terms of a plan. Let's have a plan in tackling this problem. Let's not just pick projects here and there and see what happens. So we just got to be smarter in how we invest the money, the limited dollars that we do have. We got to be smarter in where that money goes. So here's sort of my interpretation of a sustainable system. So you have the water infrastructure, you have users connected to it, and you have jobs and businesses also connected to it. That creates enough revenue to operate and maintain the system. And then you have money available to invest in additional infrastructure. So that's like how Tucson Water operates. That's how they stay in business and they're able to grow their network. But what's happening on Navajo is we don't have this operation and maintenance piece is not feeding back into the system. So it's not a cycle. You're having to put money in on investment and then put money in on the operation maintenance. So that the goal would just to be make an investment in the infrastructure to get the cycle going, and then it should be able to start the cycle on its own. So that's sort of the goal. So we developed three different studies, sub-studies. One was a cost model for actually installing water pipe. And the second one is actual design, hydraulic model to do the design. And then that design feeds into a decision support system that evaluates different projects. So that's how it works. So the first topic was this cost estimation model. And this is typically how you install water pipe in a field. And I've actually done this before. So that's kind of how I was able to develop some of this model, some of the processes, seeing it actually being constructed. So currently the way we estimate water pipelines is we just use cost data from other projects, other places. But when you're looking at some place like Navajo, it's different. Conditions are different. You have longer travel distances. You have to order pipe from different locations. So when we're trying to apply other project data to Navajo, it doesn't really work. So we need a better way to do it. So if you overestimate or underestimate the pipe costs, you can have impacts in your planning and how much money you're trying to raise for a project. So it's very important. And right now there was really no accurate cost data out there. So we just said we're gonna just build our own cost model. And when we're evaluating different projects, you need a consistent methodology to evaluate them. If I use a cost data for this project and a different cost model for this, I can't compare them because they're not on the same basis. So the new estimation will allow you to do optimization type analyses and give consistent appraisals in your water projects. So this is the process we basically tried to mimic and develop, which is similar to the picture. I'll just go through this pretty quick, but it takes into account things like how deep you're gonna place the pipe, the different slopes on the excavation, and then different embedment types around the pipe. And then we're able to evaluate different materials, so we can do steel water pipe, PVC, which is plastic, ductile iron pipe, and HDPE, which is also plastic. So these are like your 4 common water pipe. And we have essentially developed a whole cost table of different pipe types, different pressure ratings, different weights, different materials. And on top of that, we also looked at what type of equipment is needed to install this water pipe. So we built in, machine performance, how heavy of a pipe they can lift, how many water trucks you'll need. We looked at different cycle times and different capacities of different machines. So that's all built into the model. And then we estimated labor and materials based on the size of pipe, how long it takes to install. So based on the pipe, we can estimate how many people are needed to do the work, and then how much time it actually takes. And when you combine that all together, we can get a unit cost in dollars per foot for a certain diameter and a certain for a certain material. So when you have that data, you can do a lot of different engineering analysis, different designs, different options, and you can really fine tune your costs. So you can lower the cost of your system at a very high level instead of getting down into the, typically you don't get this detail until you're about to build a project, but we built this tool so we could get more accurate data early in the design process and make better decisions. So essentially the model we built will output, results like this. We can change pressure rating of the pipe. We can change the embedment material. We can change the depth and looking at different soil types. Then it gives us more detailed cost outputs in terms of how much is the labor, how much is materials, and it just gives us more insight into how we can save money for a lot of different projects. Looking at different pressure classes, pressure ratings. So in Navajo, one of the issues is you're pumping a long distance, so you got to pump over mountains, go down in a canyon, come back up. So when you have a system like that, it gets very complex in terms of design. So knowing these costs of different pressure systems gives you a better idea of the design. So we compared to other cost models, and we actually got really good results. We fell right around where other models were estimating. So the next tool we developed was an actual, like a hydraulic model to run the system hydraulic. So if we design a pipeline, we need to know the pressures, we need to know where to install pump stations, where to install pressure reducing valves. And if you're pumping over a mountain, it's very time consuming to do that process with conventional methods. So we just developed our own hydraulic model that allows us to do this like in maybe like I say a quarter of the time of what it takes a conventional method to do it. So the current methods, there's a few models that can do it. However, they have limitations, especially in locating pump stations. So this is sort of this is kind of more like a civil engineers type concept, but the blue dots are the pump stations. And if you want to move a pump in the system, you have to do this whole process to actually move a pump. But we found a way to actually have the model find where to put the pump. So it eliminates different computation nodes. And we were able to speed up the design process like by a lot. So this is one project we actually implemented this on. This is from the map before. On the north end is Page, and then on the southern end is Cameron. And then the little spur off to the right is Tuba City. So we took that system and we actually did some designs with this new model. So with this new tool, we're able to really optimize what the design needed to be so we could save costs on the project. So the way this works, similar type setup. So with this new hydraulic model, we just need a digital terrain model of the site and where you want to lay the pipe or planning to install the pipe. So with this project here, up on the top is Lake Powell, and then Colorado River's on the left, and then Cameron is on the south side, and Tuba City's on the right. So if you run a profile along that alignment, that's how it looks. So you're pumping over a hill, going in the valley, and then pumping up. So that's it's a very costly system to operate because you're running a pump constantly, and when you're pumping water, it's about maybe half of the cost of your whole system. So it's very important to consider the energy, how much energy is required to operate the system. And you want to try to minimize how much energy you're using because that all comes back to cost. It costs money to run electricity, run the pumps. These are all the equations and conservation of mass energy laws that are built into it. And we use the results from the previous model, which estimated costs, we use as input into this model. So now the hydraulic model can choose the most optimal cost material. It chooses it on its own. We pair that with a genetic algorithm, which is, we paired the hydraulic model with a genetic algorithm, which helped optimize where to locate these pumps. So each one of these locations here is a pump station. And then all the different lines are the hydraulic grade line. And so it runs like maybe thousands of simulations to try to find what the least cost design is of the full system. And so the cool thing about it too is so different pressure classes for different section of pipe or different sections of the design, we can really optimize and get the cost down. And a lot of models, they can't do that. So these are all the hydraulic processes in there. So we took the model and we ran it on this project. So this actual alignment and design is from the Bureau of Reclamation. So we took that and we said, let's see if we can make a better system than what they have. So we said, so we started to think outside the box. We're like, why are we running the pipeline along this portion of the res? So that there's really nothing out there. It's just like a desert and a few little towns, but if you actually drove, if you ever driven along here, if you drive along this route, there's a lot more scenic. You have a lot more opportunity for growth and development. So we came up with the alternative design and said, let's see how we can, let's see if we can come up with a better design. So that this tool actually allows us to design this thing in a matter of a few days versus, you know, weeks and months that it took the Bureau of Rec to design this thing. So these are the different profiles. With this design, you're just pumping over one hill and then you let gravity carry the rest of the way down. And so these are the model results, different pressures, different diameters of pipes. And then here's the other option, which was to pump over, you had to pump over two hills. So there's a little bit more energy costs in it. And this is the other design. So with our tools that we develop, we can come up with different costs, and you know, we can break out what's the construction costs, what's the operation, how much of it is the pump, how much of it is the turbines, and this is, it gives us a full breakdown of this whole system. So that tool, all these tools kind of build into each other. So the next phase is, okay, now we have a consistent way to evaluate different systems. Now let's pull it all together in one large model, and let's make a model choose which is the more economical, or which is the best option to choose. So this is a decision support model that we developed. So this is the one that, you know, tribal council, water planners, the utility company, the Indian Health Service, they would actually be able to use this tool, and the engineers would just kind of provide the input to it. So this is probably, this is actually one thing we're working on now is, we've been trying to, can we convince council or some other people to actually adopt this methodology? Because we think it's a lot better process than what's out there now. So there's really no method to prioritize projects on Navajo. They kind of just pick and choose them. So you get people doing different things. These guys don't talk to these guys, so there's no global planning, there's no vision. And what happens is projects don't get built. This guy's doing one thing, this guy's doing another. You split the funding and then nothing happens because you don't have enough money to build it. So we need a standardized method. It's going to help us focus our resources, promote coordination, and it's also going to allow decision makers to be accountable to, you know, the voters, people that they actually represent. You know, where is this money being spent that we're allocating to these projects? With this model, what it will allow is it'll give the council members or whoever an opportunity to say, you know, we're not choosing them out of nowhere, where you have a systematic process that this is the highest ranking project, so this is why we're funding it. So it also helps on their level as well. And the big goal here is we need to package infrastructure with the development, economic development. They go hand in hand. You can't talk about one without talking about the other. So this is the method we chose, which is a cost-benefit analysis and a multi-criteria decision analysis. A lot of different fields use it: economics, energy, health fields, transportation. There's tons of studies out there, so we thought this would be the best one to apply. And the advantage of it is you don't have to have costs for everything. You can have one metric have cost, the other can be on a different scale, numerical scale. That's one of the advantages. And we can customize it to however we need. We can add criteria, remove criteria. And it gives you confidence in your decisions that you're making. So this is how it sort of laid out the cost benefit hierarchy, and then you have different costs and benefits under each one. So the three we focus on was environmental, health, and economic impacts. And so these are the different, we only applied it to the 2 projects, but these are the criteria we looked at. Environmental impacts, how much water are we using? How much wastewater are we going to generate? What is the operation and maintenance costs? And then economic impacts, we looked at how much benefit are water haulers going to see when they have a closer watering system, so they don't have to travel 30 miles just to get water. So in Loop, where I'm from, they have a watering point, and people from Delcon drive all the way from Delcon to Loop, which is like 50 miles just to get water, and they drive all the way back just because it's faster and they don't have to, it's cheaper to do it than trying to get it from somewhere else. So that's a big economic impact. So those people actually gain, 2 hours a day instead of hauling water. They can do other things. So we tried to recognize that aspect. And here's how we represented that mathematically. So we just took all the different dots on that map and compared it to the nearest water source. And then if we built the pipeline, we'd have watering points off of that pipeline. And now these guys in the middle, they don't have to drive that far. So what's the difference in the distance? That's how we evaluated that criteria. And then we looked at economic development. We tried to pair what the planned development was in terms of tourism, how much traffic drives along the proposed project route, how many jobs that might create. And this is probably the toughest part of the whole project. Was we couldn't get any of the Navajo departments to have a vision of what was going to be built and where and when. So we kind of had to come up with that ourselves. And that's the hardest part of this whole thing, was just getting the involvement and getting Navajo to realize what's their vision. What are you guys planning? What are you guys planning to do? And they couldn't grasp it. And so that was probably the hardest part of this whole thing, is there's really no leadership and planning that to solve these problems. So if you guys are looking for any topics or anything to study, economic development and helping them establish a vision for what needs to happen in terms of development, creating jobs, that vision's not there. So a little side note. And then we also looked at what are the health impacts. So homes that now have access to cleaner water, they get a score. And then homes that used to use abandoned uranium sources, now they get a score because now they're not using contaminated water. And then, so people having access to clean water. So that's how we're ranking these different projects. So these are the 2 projects that we looked at, and all the dots are the houses with no water, and then the big green dots are proposed projects that we were able to identify that could be like industrial centers or tourism centers, or they have a lot of scenic areas along there. So we added scores for those types of projects. And then the circles, the purple circles, are distances to abandoned uranium mines. So if you're within the purple zone, you're more likely to be using contaminated water sources. So the closer you are in a circle, you would get a higher score on your health impacts. So that's how the whole score was calculated. And the important part is each of these criteria has a weight. And depending on what your thinking is, if you're more about protecting the environment, you would be able to rank the environmental category a lot higher. If you're more concerned with, I want to improve the economy through development and building, you would score the economic impacts a lot higher. If you're more worried about health concerns, then you score the health higher. But if you're equally weighted, then you distribute the weighting equally, and then you let the model decide what's important. So this process allows you to develop different weights for the different categories. And depending on your decision makers, they may have different agendas. One guy may be health, the other guy may be worried about the environment, the other guy may, we need some business, we need to generate jobs. So what this model does, it allows you to capture those different viewpoints and how you approach your development. So we created some different perspectives, kind of just pre-built inputs to the model. And we compare these two projects. And here's just the straight statistics that are used to make the decision. So if you didn't have a decision model and you just did a straight analysis, these would be the numbers you would have to make your decision. So if you're just given that and you have to make a decision, it's very hard. Like, you don't know, one's cheaper yet you service more people, or one's more expensive but you service more people, one's smaller but you can serve a lot of people still. So it's really hard to make a determination on which one to choose. So that's what the model helps us sort through this thinking in this process. So we created a health focus, economic development, and an environmental focus. And this is just to mimic what different viewpoints in the room might be. So based on these weights, this is kind of comparing the two projects. So the higher the score, the model favors that particular project. So if we had a health focus, it chooses the cancer project. If it's economic focus, it chooses the Tuba City, North Central Arizona project. Environmental focus, it chooses the cancer project again. So depending on your perspective, it chooses which project is more feasible and more likely to fund, varies on how your thinking is. So the model tries to capture that process. So that's just the standard scenario. Now we can start to look at what if people start to leave the nation, people want to go to school, and then they like the city, they don't want to come back. So that's a big issue we have right now. How does that affect the model results? What if we build a pipeline, but people don't want to pay for the water service? So that's another issue, is people not willing to pay. What if we build a pipeline and the economic growth that we hope for is not there? How does it affect our decision making? What if there's drought? How does that affect what we're planning? How does that change things? So we created a growth model and a water usage model that actually helped us project what these conditions and scenarios might be. And here's sort of the overall results. If we took these different health focus and run these different sensitivities through it. So if we had a health focus, the winner would be the sort of cancer project. And if we had an economic focus, the North Central Arizona Tuba City project, that would be the favorite project. And if we had an environmental focus, it'd be the cancer project. So that's what the model can do. It helps you figure out what helps you make a decision, and considering different objectives and different scenarios that play out. It's kind of it's like a tool to help you choose choose where to invest the money. So that's pretty much what the model does, and the new planning process. So this was the old planning process. So if someone were to implement this, now we have, it's a little bit, you have more upfront in the planning, and then your funding comes in at the top. So you have a big pool of money, and now you let the model decide, and then you allocate resources to the various projects as they are in your ranking system. And so hopefully what this will do is it'll allow the utility company to actually see some returns on their investment and help with the operation and maintenance costs. So we get back into that sustainable type cycle. So in summary, we created 3 tools. The one that the tribes are more likely to use themselves would be the decision support. We tested 2 projects, but you saw on that map, there's like 8 different projects. So if you wanted to extend this, you could evaluate all those other projects. And so the goal is these tools will help Navajo make some better decisions, more robust decisions. Hopefully this type of process will improve some of the poverty, socioeconomic conditions on Navajo. So that's the overall goal. If you guys are looking for any study areas to, relate it to this, there's a lot of research needed on model inputs, like how many homes. We couldn't get an accurate idea on how many homes are on Navajo. It's crazy. The Indian Health Service, they couldn't give us a consistent answer. Every time we asked them, they give us a different number. So the data is not there to really refine this. The economic piece, vital. There's no vision for Navajo to, to paint out what needs to be built and what they're actually like trying to do. Other planning departments are needed to be incorporated, and the existing infrastructure capacity, there's a lot of study needs to be looked at that. And then we never got to actually have like the council or decision makers develop the weights. So that's another piece that, this is the part we're actually trying to work on now, is let's actually get them to use it. So that's pretty much it. That's a summary of the research we did, and through the company now, we're actually trying to get this implemented on Navajo, and hopefully they can buy into some of the ideas and use some of the tools, so we can actually change the planning process and help improve Navajo. So that's pretty much it. If you guys have questions, I don't know how much time we have.
We can do about 5 or 6 minutes for questions.
I just have 2 questions. The modeling, did you get it copyrighted under you or just under the company name? And 2, which agencies in Navajo you think are most progressive to implement certain projects?
So we started to do the copyright for some of the software. We actually got a paper published for one of them. We submitted one, but we never finished publishing it. So we are actually now, through the company, we're trying to copyright some of these software, especially the cost tool and the engineering tools. So that's on the engineering side. For the decision-making software, I don't think there's really no benefit to copyright it. I mean, that would be a tool for the nation to actually use. So my goal is, if they actually wanted it, I would just give it to them. Say, here's a tool, use it. There's no benefit for us to have it, And then
Which agencies, East, West, I used to work for Water Resources.
Oh, okay.
So I'm just curious, what have you seen recently? Like which agencies, Eastern, Western, or South area, or Shiprock area?
I don't know if it's really broken out by agencies, have different viewpoints. Like I feel like the need is consistent across all of them. They all want water. They all want growth. They all want, things to change. But I feel like it's more in the council. The council is where all the change happens and where legislation gets passed and it affects everyone else. But I mean, you take one chapter and compare it to the other. I mean, they all have similar issues. They either want, some people want change, some people don't, and it's hard to section it out, I guess. In the back.
You had outlined the decision-making model, the environmental, health, and economic concern. Was there ever any thought about trying to also capture spiritual, cultural, as one of these aspects?
I think that's probably, we tried to capture that in the environmental piece because we knew that, the more water you use, the more likely people may be opposed to a project, and the more waste you're going to generate, and you got to put the waste somewhere. So the larger the project, the more environmental impacts it would have. So people would likely be more opposed to it. So I guess that's sort of, we tried to capture that, but there's so many things to consider that we, and it'd be really tough to quantify that or come up with a score to actually do that. But that can be something to add in the future. And
seems to be important because at many points you brought up, I can't believe that we don't know how many residences are there. Culture may know why people don't necessarily want to say, hey, count me. In the white culture where you have senses and that kind of stuff going on. So
yeah,
that's one.
Yeah, it's important. I think.
Wondering why drilling wells doesn't seem to be part of the discussion, and considering how expensive pipelines can be, is it that drilling for wells is just even less viable?
So I asked that question when I first started, and based on NTUA, they understand, they operate all the wells, and they said we're essentially maxed out on what the wells can yield. So even if we drill more wells, we wouldn't be able to pump more water. So a lot of the system's already strained to what the resource can actually produce and yield. So that's why they're looking at these pipelines to bring in actual surface water. In reality, you probably would want to try to balance, have some surface water come in and also balance with some of the groundwater resources. And a lot of the groundwater is very brackish. He knows a lot about that. A lot of salt in the water, so the treatment cost is very high. So these pumping in from the surface water is essentially pretty much the most feasible and viable option at this point.
So I was just out of curiosity, I was kind of surprised that the Yenta scored higher than the one coming down from Page to Cameron, and considering that the one coming from Page to Cameron is the former Bennett Freeze area. And so I was wondering how some kind of historical trauma event like the former Bennett Freeze area that put restriction on development would be considered into the weighted criteria and scores into the model.
Yeah, I kind of thought about, well, I knew about that area, but that's one of the things that's really hard to capture, that aspect of it. And the whole thing with this is we have to try to quantify the metric in a way, either on a numerical scale or some sort of scale that, I guess the hard part is to try to quantify that piece. So, I mean, those are some shortcomings of the model, is it doesn't capture things like that. But those are important things to consider. It kind of goes back to his question, who who's more for a project and who's not for a project. Yeah, I mean, it's there's a lot of things that we didn't capture or weren't able to capture, but that's something to consider in the future. I mean, let's say you did come down to these two projects. I mean, in my mind, you wouldn't let the model choose exactly for you. You'd have that discussion with council and say, you know, here's, we narrowed it down to 2 options, so let's pick one and let's talk about things that we're not capturing. So that's how I see it. You would have to, there's still some input that you would have to have on the decision. Did you have one too?
Yeah, I was just wondering if you include like sources of renewable energy to help with pumping the water through your pipes, like using solar panels. Do you, I guess, experimented with that?
We haven't. It would probably affect a lot of the decision because right now we just assume that we would buy the energy at the current NTUA's rate. But if you added that aspect in, which you could actually quantify that, it will probably change some of the decisions. But that's part of the pieces. We tried to ask, you know, is there any renewable energies or any type of energy projects that you're looking at? And nobody could answer that question. So we wouldn't know where to put that. We wouldn't know where to put it on the map. But that's a good point.
Kind of relating to what you just said, you mentioned several times in this talk that the lack of economic development vision among the Navajo government agencies. You have any thoughts on what's the basis for that? Why there's this lack of vision in the nomination government?
People don't want to think that far ahead, I guess. Yeah, I mean, I think a lot of it's like I feel like a lot of the issues on Navajo too are sort of driven with almost like a poverty type mindset that affects decision making, even affects the leadership. They get, because I've never worked in the government, so you know, being in a place and just having those, and a lot of their decisions aren't necessarily their fault. It's a lot of the structure that's there, the way the departments interact, and it's kind of just puts constraints on how they see and visualize. So I've never worked in there, so in my mind, I'm thinking a little bit outside the box and probably what they're used to, and so I don't know. That might be part of it. Just the structure and the way things are set up, that's probably affecting a lot of the thinking.
So we're working with the Saley Water Users Association, and they received, I think it's $3 million from the C. Hudson Fund to revitalize their agriculture. And I saw the PDF of the ratings that different community projects received. And I never knew how they got that score for these hundreds of different water projects. Do you know how they come up with the score now for their water projects?
I'm not sure. I know for the like residential use and water systems for homes, that Indian Health Service has their own scoring criteria. They have a ranking system that they use, but as far as irrigation, agriculture projects, I've never heard of the nation having anything like that, any kind of scoring system. So yeah, I don't know how that.
I'll email it to you.
Yeah, that'd be good to look at that.
Quick question about the model. So you have the 4 different types of pipe, and how long do each pipe last in the environment in the Navajo Nation, and then how long in the future was the model predicting for the operation?
So, I mean, depends on where you look, but a lot of these pipe products, a lot of them say like 50 to 75-year design life. And the model projections we ran out to operation and maintenance costs, we did 50 years out. So it's, yeah, we tried to stay consistent with both.
That influenced the discussion with the tribal leaders on their economic future plans?
Yeah, well, a lot of the stuff we use, there wasn't vision out that far. A lot of the vision was immediate projects within maybe the next 5 years. So that's sort of the big missing piece of the whole thing, is that long-term vision. What do you guys see 20, 30 years down the road? That's probably the part missing from all of this. Very important.
Okay, well, we want to, was there another question? Okay, one more question.
Okay. I have two quick questions, but the first is about the model and for your cost model. So your 4 inputs, which input had like maybe the biggest influence on the cost?
For like the pipeline design, or
Yeah, for your first model.
pipe material costs, the biggest cost piece. The larger diameter you go, the more the material comes into play. So the material cost is very.
And my second question is, because it looked like that the first pipeline, the Central Arizona, goes over that big mountain, which is probably like the pass, right? But I was thinking, did you guys look at maybe trying to get the water at the bottom of the dam, then come in maybe that way? And by the time you get down, you can maybe a shorter, thinner diameter, less energy to pump at the copper mine?
So we didn't look at that option, but I mean, you could, with the tool, you could run that option as well. We just chose that source location at Lake Powell because a lot of the studies said that's the most feasible intake location. So we didn't really want to mess with that. But I mean, you could essentially take it off wherever you want it and run the pipe from there. But yeah, either way, you still got to get to the top of the hill. So if you took it further downstream, you'd have to pump up higher. So the further upstream you would locate the source, the less energy would be required.
Okay, well, thank you. Let's thank Ronson for coming.